not by chance the Richard who set all this up, are you?
Yeah.
Very good job. Appreciate it.
He's actually fully Okay.
Yes. You can talk if you want, but no, it's my turn. So I'm very interested in what you have to say. So anyway, we do have this new language coming in. I don't know how to do this. I can do this.
What? There's a microphone there, John. Do you want?
Say again?
There's a microphone there if you want to use it.
Oh. Microphone. This is going to be hard. All right. So yes, we have a new facility, and the name of which I'll go into in just the first second slide, but just to clear up the little confusion, what we're calling it. I think the name that will stick is the Domino Query language. So people who we're calling it the Domino General Query Facility (DGQF) find this a bit easier to pronounce, and it might be DQL. I don't know what the formal pronunciation. I like pronouncing my acronyms. I find it very creative. So if you do that, this is DQL. That's what we're talking about here this morning. So the application strategy discussion I just made, it's not really prerequisite, but it lays the groundwork for this. So I will go through, there's some redundancy here, but in general, this is a deep dive. This is saying how it gets done. So you can either check that one out, or I'm going to share the presentations. I have no idea. Okay. So just to set some expectations for the session, there'll be lots of detail, and most detail is subject to change. The good news on that one, there isn't much time to change it. So it's great. And all future features, enhancements are speculative. People have questions about, have you done this? It's probably no, not yet, because this is version 1 of this, and it's something that we're just getting going, and I need to gather. I'm very interested in gathering those kind of requirements for the future. Okay, and yes, comments are absolutely encouraged. Okay, next. Okay, every talk has an agenda, so there's my agenda. Good. Okay. So, the name, yes, it's under construction, but I think we've settled on having DQL. The query facility, DGQF, is actually the code that satisfies these queries. Okay, it is that which runs against Domino in a general query kind of way and comes back with results. DQL is the language with which it does that. Okay, it's the language you specify, you write, which does that. It's actually a second language. We threw the first one away after 3 weeks. So it was basically the Mongo style building tree, which I'll go through. Okay, the target developer for this whole thing really was the NodeJS neophyte. Someone who doesn't know Domino. Someone who hasn't had experience with Lotus script or formula language, doesn't know about the design center. Okay, but once the concept was proven, that took a couple months, it was just an easy thing. An easy effort to say, let's make sure that we add some functionality to the back end, Java and NodeScript as well as NodeJS. And there is a command line invocation, which I'll show you as part of the demo here. By the way, that command line was how it was developed. So it's not something that I haven't used. It is used all the time. And if you don't know Node.js, I'm being kind of a weird evangelist for Node.js. I didn't set out to do this, but get to know. 2018, you should know Node.js and the power which is provided for you by the query facility. By the way, if I say query facility, that's what I mean. I'm used to saying it. Query engine, that's what I mean. If the word query shows up, I'm talking about this. Okay, so that's the power you get from Node.js, even from command line, is profound. Okay, language constructs. The syntax, identifier operator value, or @ function values, an optional value inside. Those are the 2 things we do right now. You cannot say value operator identifier. You cannot say identifier operator identifier yet. These are things that are coming. So field name, creator field name is not supported yet. Identifiers are, again, summary field names. Let me mark my slide. Okay. They are, some operators need to identify, but the operators generally are pretty well known. Greater than, less than, those operators, plus the in. Now the in function, the in operator has a modifier called all, which basically says I want you to take the values inside the in list and AND them together. Without the all, it ORs them. Okay? So I'm going to speak with ands and ORs a lot. ANDing and ORing their verbs. I and, you and, that kind of thing. So that's how I'm going to talk. Identifiers are summary field names. They're not non-summary. We don't do non-summary yet. Okay, that's coming probably in Domino 10 when we do the full text index. You can look on summary fields and ask questions about that. We will find no documents if you use a non-summary field. That's what's going to happen. Boolean support, ands, ors, and nots. Very common ways of specifying, of tying together multiple terms. And there is precedence of terms. That is, we will apply Booleans in a certain order. And the rule goes like this: ands before ors except after nots. So that's basically how it is. That's set theory. That's not something we invented. That has been around forever. And you can override it with parentheses, which is kind of classic. See? People have done that forever. Okay. So let's talk about it. So the constructs, the identifiers and operators, a view column name is a type of identifier that I haven't talked about yet. View name in a single quote dot column name will basically find a view and will find its column. That column can be filled with data from a formula language. Domino lets you, extrapolate data and put it into a view. It will use that set of data to do the search. Okay, so you basically, it has to be like this. It's the programmatic name, not the column name that you see. That's the beanie, or the beanie, and you find out the programmatic name, whatever it is. It can be $ number, right? So we assign those names if you don't name them, okay? But that's the name we use here, okay? All identifiers and assign functions are case insensitive. This language doesn't, we don't care about case, not for the operators. And the value data type determines the type of search. Domino is typeless. Okay, it is typeless. People like that about it. It's what makes it NoSQL. Domino is the first NoSQL database because it is typeless. It is different than SQL. SQL makes you strongly type everything. If you make a mistake with the type in SQL, you get an error. Not so with this. Not so with DQL. Okay, so in this case, we have 3 different types of data, basic types of data you search. And depending upon the type of the data, of the value, we will do a different kind of search. You can use the same field name with each of these, and we'll just go ahead and try to find the value. Okay? So it is not typed by the field, but by the value. That's the difference, right? So a string, by default, is case and accent insensitive. If you want to add those sensitive, talk to me later. I need to know how best to give that to you. We can certainly talk about that. For now, it is that. Legal data values may change by venue. That is, the backend may tolerate more than Node.js. Yes, sir?
Date or daytime?
Daytime.
And
Yeah.
then what?
Sorry.
Okay. And it is shown as the university time zone?
It is in, it will be in GMT.
Yeah.
Yeah, always, yes.
Yeah. So
With the plus and minus operators.
Yeah.
Yep, yeah. And ISO 8601 will always work across the line. We may give you other things in the back end. We're still sifting this out because we want to conform with the environment. Okay, and that's where we have to go there. Numbers are floating point notation, including scientific key format. So you can do that. Let me show you this point. Figure out how. Here we go. Sheet anyway. So put this down. Okay. There we go. Now we'll see it. Is that too small? I can make it bigger.
It's bigger.
No, I can make the font bigger. Sorry, this is brand new. You can obviously we can tell. It's new. All right, so let me. Okay. So running demo one. This is running a tool called DOM Query, which I'll go into as we go through this. These are all queries just flying by here. You can see the different types. They run in basically sub-millisecond or maybe a few milliseconds. These are queries that run against a database. And I have pretty much all of the data types in this basic set, and also the type of search being done. So you will see that there are, go back up here, the E formats, if we have these things. So there's a date, see the in all with dates? So you can put these dives anywhere. So these are just some of the complicated constructs. This is not even starting with Booleans. I haven't added any ors or ands. This is just with the set of things we have. So the explain output I'll go in through. I'll explain. Oops. Sorry. Here we go. Moving up. I mean, it all ran very fast. So I just want to go through the sets of data you can see here. I wanted to find a number with E format so you can see that as well. It's all there, trust me, but I wanted to show you. Yeah. But there's a number range, so you see that that number range 5 in all. That is finding documents. Number range is a number list of the document. So that says that documents have to have both values. Okay, so in other words, there's a repeating list on the document and make sure it's array processing. Okay. A little bit more here. Where the ends. This is the end section of the queries. Well, there's an end all. We can look at that. So you see this construct. Oops, sorry. Sorry. Anyway, I wanted to show you that. So there, I wanted to show you the way we can combine the insides of fields, the insides of views in the same query. So in the in statement, the in operator without a field name takes the list of strings inside of its parentheses and matches them against view names and folder names. Okay, so if you have folders that have interesting documents in them, you can pull that in automatically very quickly to that in syntax. Okay, let me go back to the presentation. Wrong one. Sorry. Okay. There's the one. Okay. Okay. So how does the DQL use existing design elements? Since it is high speed to use things like views and be able to access them at compile time, it was necessary to pull those design elements or the information about them into a separate place for high speed access. We couldn't compile. If we opened every view node in the database to compile a query, you would get it back sometime tomorrow, basically. So we pulled it out. The extract is called design harvesting. It comes out with a design catalog, okay, and design.cat is the current name of it. It's used for housing metadata for views and columns. So you can all those different syntax options are supported by this, and we must pull it out in a separate place. And no, you can't access it. And the reason is we're not committed to it. Okay, we may have a much better way of doing it. We've had some security issues already with it, but the idea is that we need to have a fast access. The problem to be solved is to be able to look across your views and see what you have for columns to satisfy a query. To do that, we had to create a separate structure called Design Harvest, and the design catalog is what we're calling the place where it's stored. Okay, so in general, you should understand this is a theory.
You have one of those for every database?
No,
Is that?
one for all. Now, we may that is actually the alternate, the major alternate design we're talking about, which is actually make them show up in the database. The trick in the database case was not to make new notes for you. In other words, if you have a select all view, all of a sudden some new notes show up. We're not doing any favors by doing that. So we have to have a way, potentially a proprietary @sign function. We're not done. But we have, so for now, design.cat, design.cat has information for all databases that you specify. After all is how to get it in there, I'll talk about that. Okay? In general, harvesting and exposing existing designs will be the theme going forward into Node.js. Okay, so the work you've done to create ACLs, forms, views, all the stuff you've done in Designer, we're trying to find a way, and by the way, it's really a very powerful thing we already have. In fact, Domino has many advantages over existing Node.js suppliers in some of the functionality and the data that we have. But the trick is to make sure it shows up in Node.js in a way that's consumable by neophytes. Okay, that's really the trick. But that is a theme going forward. Okay, how do we do this? We do updall, and there are two new updall flags. Updall database path -D for refresh, and -E for rebuild for this database. Basically putting, what this does, it puts the design catalog data into that new file I talked about, or it will, something in the future it might change how we do it. But this is how you tell the DQ engine about design changes. Okay, it doesn't happen automatically. We may change that as well, but for now, it is updall -E, and I'm going to show that. Okay.
So we can schedule that as a program.
Absolutely.
So it is automatic.
Yes. Yeah, you can certainly do that. Yep. And so without that, all query terms will perform NSF scans. And the view name, column name terms won't compile because we don't know about them. Unless we pull it out, we cannot guess. If you know the internal structure of Domino views, a column name is one of many sortable columns. To find out which one, we had to pull the data out. Okay, I will now try. Oh, good. All right. Okay. Okay, this will run. If you were the previous discussion, the previous session, I specified 4 queries as part of my presentation. They all run. And this is those running. And we actually come back with a set of data. But you notice the last one here, we have not run updall yet. Okay, so all we have, everything we do here, see the scanned darks? That means we have done, and it says NSF document search. That means that all we're doing is scanning NSF. And if you do that in a large database, it'll take a while. Actually, it'll fail because we have limits. We don't let you do that. Okay, so let's go ahead and run. I think this is to A to B. Yep. And you see this time, see the entries, the bottom one, very bottom line, entries equals 388. That means, and because it's view-based equality, now we know about views. See, now we have the goods to be able to figure out, we have a faster way to solve this problem. And that's how you get it in there. So again, the query engine works. So DQL will work to a point. If you specify that soon-to-be special.status, we can't figure that out, so we'll fail that query. But everything else works, quote unquote. It just will be a bit slow. Okay? So after running updall, let me show you the updall. It's above in the stack here. Sorry. False move. There it is. So you see the line rebuilding design catalog? That's up top. Rebuilding design catalog against that database, and it says 2 view designs cataloged of 2 total with 9 collations. Basically, a collation is an index. And this took a whopping 35 milliseconds. It will take a large database. We have a fairly large database with 600 views. It takes about 15 seconds to run. That's fast. I mean, it's perfectly good to run during the day, or there's no happen. So 15 seconds will be. That's all it takes to catalog. Yes.
Did you say 600 views?
I cannot hear you.
Did you say 600 views?
600. This is not. Yeah, 600 views. But you know, that's the Domino Design Center makes it easy to create views. You see. Yeah, that's a key point. And you know, I think this, if you're moving into the space, it's a good time to clean some of that stuff out. You know? So it's always been a battle, right? Because people want documents to show up in a little different order and categorize and whatnot. And the power is there. The trouble is that you don't want all of them, I think. But we have no way to filter out those 600 views right now. So it's getting those. If you say a database is ready for DQL, you're saying that. Yeah, we want them all. Okay. Back to the presentation. Again.
Is there any specific reason why you don't update that automatically, just like any other updater?
Yep.
Okay.
Never mind, I'm not going to say that. Bug for bug compatibility, yeah. Okay, so I'm going to talk about Boolean trees, because this is how query engines work. And you see those are, I have 4 ANDed criteria up on top. And what it becomes internally is this. The AND node sits above all the leaves. Those bottom ones are called leaves. So the idea here, and the beauty of this, is you can execute those leaf nodes in order according to their cost. So the cheapest one I think here is probably, well, yeah, order equals Detroit. So that will, we figure out what the cheapest one to run is, and then we inject, next slide. We inject the results of that into the next node, okay, the next leaf. Now, I'm sorry, I didn't finish the thought. Yeah, and the Boolean nodes control performance. So the Boolean node on top, the AND node, is smart about what runs underneath it. And each leaf node is smart about what preceded it. Okay? Doesn't matter, but the order doesn't matter, by the way. People ask that question. If I take this in a different order, no. We will still figure out what the most important thing to run is, the fastest thing to run is. Okay? Okay. How do you qualify? This is the small print. How do you qualify a DQL view column for solving a field operation via query term? Well, the view must have the select all, okay? Because without that, if you don't select all, you already have a set of criteria. You can't end that with something else. It must be a select all view. It must have a collated column. Obviously, this is either it's the leftmost in the view, and you said sort by ascending, or it has that click by column headed to a sort. Okay, each of those, and when you bring the view up, it has a little caret for sorting it. Those are the columns you can look at. Okay, those are the columns of the process. It must be non-categorized and show multiple values as separate entries.
Yeah.
Okay, because of the way that Domino allows text lists. In order to make sure we do a good job with those queries, we must have them all in the view. Okay. Now, if your experience is the same as mine, this is a small minority of all the columns in the view. Okay, and that's right. It will be. So you may want to create some more of those. I don't know. Or if you want to use another column, we give you the other syntax. Okay, the view name.column name. That gives you another way to get there. You specify the view and say, I want to use exactly that column. And that combines 2 things, right? That combines view selection criteria and the term. So you have a set of selection criteria that that populates that view, of course, that's already there, that's already applied, and we will on top of that apply your term, whatever it is, equals, greater than, whatever you say. Okay? So that is, yes, sir.
Is that approach faster?
Which one's faster?
Yeah, in terms of performance.
They're equivalent.
Okay.
Yeah, I mean, you measure performance with DQL by how many entries it processes or how many documents it scans, which is why we have limits for those things.
Okay.
Yeah.
So your first statement there where your view must have select all. So if I have 100,000 documents in my database and I narrow a view down based on selection down to 20,000,
Right.
I can't run the DQL again.
No, you can't. That's why I said you specify.
So this is no more.
Yeah. The bottom, that's what right. So either you do that or you do the other one. So that is what I'm talking about at the beginning is a raw field name in the query. What I'm saying at the bottom is that if you don't have a view like that, it's cool. You just specify view name dot column name. Okay. Remember, this is built for neophytes. People don't know Domino. They want to say field equals value. Okay. So if you don't have a view that matches, that's fine. You can go ahead and use the other syntax. Works great. I do it all the time. Okay? Right. You can only use, but yeah, I should say yes. You must have that a sort of a column, same thing, for that value. So it must have a collation on it. Without that, we can't just pick a random view, a random column from your view. It must have a caret or be leftmost in the sort order. Okay? This topic is really just why do views exist, right? They're visual. Okay, they bring up a set of documents. But under the covers, they also have indexes. That's what this leverages.
So the first one just is smart enough to go find an index because at all.
Yeah.
And you get to be smart in the second sentence.
Yes.
By specifying
Yes,
more
that's right.
filter.
I mean, you know your data. You know the views you want to search.
Oh, yeah.
And by the way, all view aliases work fine. So any alias you have, work with this. Okay? You can just spell the whole view out. Okay.
Do you have a way of recording views that are being used by the et al? Or,
Not at this time. At all?
well, that have the select at all in them, so that they.
Yes, we do. We don't expose it yet. But yes. If that makes sense. So.
It would be nice to know that.
Okay.
So I know what views I can possibly serve, so
Right. Okay.
maybe I need another one.
Right. Right. Well, that's, yeah, okay. That's a good point. So that would some way to peer into the design catalog to do that. Okay, good. Good
I
point.
want to access the design catalog.
No. Right, you can't. No, you can't do that. So in general, view searching is faster than NSS scans, particularly for small ranges and equality searches. It is. If you want to optimize a document scan, create a compliant collated index column. Okay, if you want to make something go faster that way. NSS scans are summary only. No summary data, no non-summary data is included, not in Domino 10. We may well add that in Domino 11 with full text. Okay, full text support. Okay, that will allow you to search everything. But for now, it's just summary. Okay. Andy and Oring, I've mentioned sibling operation. Any set of terms can be entered or ordered at the same level. Now, so this is an example of what I was talking about, the injection idea. So order number greater than that number, or salesperson equals Trudy Ayton, would probably choose the cheaper one. Trudy Ayton would win that or. She would get her documents found, and that set of documents is injected into the order number query. So we actually have a pre-filtering option that goes into this. And we just take it, we figure out the results, and pass them to the other nodes. Okay, which means they shrink in cost. Right? And you'll see that in something explained of it. Okay, these are snippets of explain. I'm going to show explains in some more glory, but this shows you what's happening with this. So here we have the order number. This is an optimization we perform. I told you this detail. This is an optimization we perform between two range terms. We say, okay, start here and go to here. So we go to the view, we start it at 146.751 and stop at 150.111. You're glad we do, because we can walk to the end of that thing. So it behooves you, if you know a range, to say both sides of it, like this. Okay, we'll find them, and it'll be very fast query. You see, this took 21 milliseconds. And that, the numbers of documents it found right there is 558 in that range. The second part of it was free. Okay, we're saying we did nothing to satisfy that, we just bounded the first one. Okay, so if you see that coupled with earlier sibling, that's what that means. Okay, again, the order doesn't matter, you can have these reversed, we'll find them and run them. Okay? All NSF scans, whether the AND or board, are satisfied with one pass of the document summary. So in other words, we don't pass it multiple times per sibling. We'll pass it once and satisfy them all. And we will also avoid searching the documents that are already found. So if you have found something, the second term won't be applied because we already found it. Okay? And NSF scans are also smart and pre-filtered with possible. If you have an NSF scan showing up with a view scan, the results of that view scan are passed as a pre-filter to the NSF scan, shrinking it in cost. Okay, here are the maximum limit settings. Okay, we are keeping, is Andrew Pollock in the room? No, he's not. He approached me and he didn't really talk meanly to me, but he said, "You're killing my server." I said, "You're darn right." Yeah, the server, if you don't have limits like this, you have a potential, and we have to give programmers power, okay? But limit them, please. That's the point here. So the idea is that we have settings to keep this thing from running away. The first of which is the maximum document scan. And right now, I just put the defaults. The defaults are subject to change, and you can change them. I think I mentioned this, yeah, at the end. But so that's the first one, document scans. That's the whole query. You scan one more, we'll stop. Maximum entry scans. View scanning is not free either. Okay, so that's something we want to make sure you don't run away with that. If you scan a big long view, you will take the CPU away. Okay, we want to make sure you don't do that. The last one is the maximum milliseconds, and we don't check every millisecond. but it is a way to, at certain points, we throttle your query and say, okay, out of the water, you're taking too long. And I'll show you the experiment. Again, limits are checked periodically across all operations. They can be overridden two ways, either with a node city setting for the whole server or per call. All of the DQL calls will have these limits settable. So if you're at midnight, you don't care what happens to your server, whatever, you know it's a downtime, knock yourself out. Create a query that eats Chicago. We're in Detroit, so no, it's not. Anyway, and if they do get exceeded, you will return an error and no results. There's no way a partial result can be computed for this. Once we're timing out, all bets are off. So we don't. Let me show you this. So the first one passed in, this is, by the way, through using the DOM query utility. The first one passed in, I think it's is the milliseconds one. So you'll see, we don't check every millisecond, but we do stop. So you passed it and gave it 2 milliseconds to run, which is ridiculous, but I had to make it fail for the demo. But the idea is you'd see the operation time limit exceeded, and indeed the query took too long. It took longer than 2 milliseconds. I was being kind of rude on that. Okay, the next one checks for document scans. You should see, there we go. This does check every scan. So I wanted 100 document scans, and the 101st failed. Okay, so this just shows you how it happens, and it stops it before it runs. Now, of course, the numbers will be much larger. Introduction, you said it's something that works for you. We're still in the middle of performance testing, trying to find good defaults even. So, and they may not be your defaults, but that's why the node city setting is provided for you if you want to provide it. Okay. Right. And my entry for the most busy slide of the conference is this. Yes, and there's, by the way, it's on Twitter if you want to come up and find me on Twitter. And this shows you the explain parameter, the explain tool. Okay, it's a tool for showing the Boolean trees that's used to process your query. By the way, Mongo makes you type this in like this. That's your query, that language. Okay, you have an OR node and then a bunch of JSON underneath that correspond to the field value lookups. We had such an interface that was DQL1. We threw it away in deference to what we have now. Okay, so briefly, there's a lot to go through here, but you can see that the top level 0 is the node that owns it all. That is the OR node. So you see there's 2 ORs. We make it 1 OR and have children underneath it. That's how it works. Okay, so there's 3 children. The first one, we list the actual value being sought, and by the way, we will turn dates into dates that are different than you specify because we have to do that. And we have a basic choice. Either we're doing an SF document search, you see that part no, that's doing a document search, and we have an estimated cost. This is our first attempt at saying, you know, this is more expensive than this, more expensive than this. It's a way that we order them, okay? So they were not executed in order. They were executed by, I think, 1, 3, and then 2. It should have been, yeah. So that the NSF document search would happen last because its value is higher. You see that's how we order our results here. Deep dive, that's what we're doing. Okay? And the timings below that show you the prep time. If that ever goes to a millisecond call needed, that's something wrong. I just put that in there to say we have to do some work to figure out how to solve this term. And that's how much time it took. It's negligible, small. Exact time is how long it took to actually run. So yeah, order equals that number is instantaneous. That's less than a millisecond because it's a view search. Equality search is the fastest thing we do. Okay, so that's fast. They found 1 document. The next one would be the third one, Detroit. That also, you see the entries on the bottom there, 55409. That's how many view entries it scanned to solve that. Okay, that's a bunch of entries. Okay, that didn't hit my limit, but that's a bit of view processing. And then the middle one is the NSF document search node. Term, and that has scanned documents. You won't see both entries and scanned documents being non-zero. One of them would be 0, the one that we didn't do. Okay, and the found doc is already there now. I will say, as a caveat for this, because of security reasons, we may have to remove that found documents. In other words, people can run the DQL and figure out intermediate results and figure out their documents that count of documents they shouldn't see. So that's a current concern in our development. Okay, but that's pretty much it. So again, if you go to Twitter, you can see I posted this as my presentation, my entry for the most busy slide. Okay, so here we go into security. We honor readers list. Yes, we do. It does slow down view processing, but has no effect on document scanning. Okay, basically, it's a wash. In view and folder extraction, the in clause without feeding, they can be very expensive when publishing reader lists because we have to go through them all. We can't pull documents out of that term without hitting them all. And so that will require us to look at things you can't see. I mean, we don't return them. We have to check every one. See, when ORing and a view has lots of documents, that may well exceed the view max entry failed query. So you will play with those maximums and you'll find out what works, what doesn't work. I cannot dictate. There is no way we can dictate what works in your shop. We can't. So, but the point is, you do have limits. You can't control them. Okay. Right. And this is why the design catalog cannot be shown, because there are ACL protected design elements, views that have ACLs on them. We have to design catalog them to run queries in case someone does have access. We can't show people. Okay, and this is the trick. We're still looking at this one. I'm being as honest as possible. And we may have to say, okay, in fact, ACL protected views can't be part of this. If we can't solve that robustly and in a way that is rock solid. Because obviously you have those ACLs there for a reason. Okay?
non-summary field.
The
Oh,
non-summary,
yeah,
okay.
okay.
Yeah, you can't review those. Okay, query. This is the tool that we built the tool with, built the DQL with. The different options are here. This may change name, but DOM query is current name, dash F is a database name. It's got a relative path that's required. There's two ways of supplying queries. One is a quoted string, double quoted string. That's through dash Q dash Z tells it passes in a file of queries. Okay, that's what we test with for the most part. Explain is a common thing. I never run without putting explain on. Basically, it dumps the how we solve the query. That former explain slide. That's what shows up if you say dash E. Let's go on. Parse only for testing. That basically says, is the syntax working? I may, if you want, I can demo the errors that we put out there. It's pretty good. We point to where we choked reading your syntax. And by the way, I type in that query, so anyone else will as well. It's convenient. You get the right quotes and forget to close parentheses, all this cringy stuff. And then the maxes, okay, maximum views, maximum number of documents, maximum number of milliseconds are all passed in that way. Dash X is X and on error in the case of the file. And if you want to force NSF document scans, okay, and we do this for testing, it's there if you want to use it. Dash J will do that. And you can take the, if you want to put this to an output file, dash O does that. This will run on Windows and Linux, and it's handy. Okay. So it does not put out data yet. The output is explaining. Okay, that's what comes out. If you want to have document output coming out, learn NodeJS and use a DominoDB module. That's what it does. Okay, the bulk read document method is awesome at that. Okay, and I recommend the dash E mode. That tells you whether it will tell you how it gets run and help you tune it. Okay. Okay, let's do the last. This is up to 2. This is well. So this demonstrated the three runs of the dash Q option, where you're specifying the query in line. You see that line by the middle of the page there, DOM query dash Q. That is how we pass that in. Dash E at the end there for explain. This runs and produces the explain output below. Okay, so I ran that 3 times, 3 different runs of DOM query. The next one is going to run my test bed. Stand back. There we go. So this runs, you can put any number of queries you want inside the file. This is going to run for about 2 minutes. And it will come back with a set of documents. You see how fast they fly by. These are simple queries. They're not, and as they get more complex, it slows down a bit. At the end, I have what I call super queries with about 25 or 30 terms on them, with ands and ors that would make you blind. So I don't want to do that to you. So I'll let that run and show you that I can do other things in my machine while it's running. I think. I used to be able to do things like that. Nice one. And I think, yeah, that's all. So are there any questions or discussion points? You can, by all means, hit me up there. Yes.
Is there an order by in the query?
Yeah, order by and group by and aggregates and those kind of things are all post-processing. NodeJS will support those. Inside of LotusScript, it's a document collection. You guys know how to do that already. It's available. Document collection can do that. So that's in the back end, Java and LotusScript. It's a programmatic task for app devs. Okay, and that's actually a programmatic task in any case, but we actually supply, will be supplying group by and order by variants in Node.js. Yeah.
Grouping, sorry, aging.
Pagination, unsolved problem right now. We have to fix that. We have to make it work. I don't really have an answer for you, but yes, we know about it. Yeah, so we better say, yeah, you can't. We're not going to return 1 million documents. We're a little nicer than that.
But then you come back to grouping as well, because then.
Yes, that's right. So then, again, the Node, it's not really a NodeJS demo, but NodeJS does all that work server side. Right, that's the good thing. You don't specify, it doesn't only sends the data back when it has something to show you. Or you say read them all. That in this case you asked for it. Okay. Okay, that's it. Thank you.